you're going to have to use the definition. So there's a class opener. Find the slope of each secant line, and find the slope of the tangent. What does the secant represent? Average rate of change. Okay, Matt? This is average rate of change. And what's the tangent? Instantaneous. Great. So I want you actually to find the slopes. That's too long a word. I spelled it right, didn't I? Instant and then taneous. Okay, Grant, you don't have anything written down, or do you? What is this? What is the slope here? What is the slope? You know, don't make this hard because it's not hard. Yeah, it's just the slope between those 2 points, which we all should know. Cold. So it's f of a plus h minus f of a all over. Well, it's a plus h minus a. Well, I like to see that. I like to see that because then I see slope. What about this one? What's the slope here? This is the alternate form for the derivative. F of x minus f of a over x minus a. So what's the difference between the secant and the tangent? What do I have to do? Take the what? Limits. You're going to take this point. We'll see if it connects that. And you're just going to drag this down the curve. Oh, I forgot to put it down now. So you're just going to drag it down the curve so those points get closer and closer together. So what's this one? This is the limit of f of a plus h minus f of a all over h, you said, as h goes to 0. Now, on your quizzes, so far, that's what I expect you to use in your homework and homework quizzes. So if you need to practice, you need to practice. Because sometimes the algebra can be not very nice. Right? What about this other one? It's the limit. That changes. It's f of x minus f of a all over x minus a.
As x approaches a.
As x approaches a. Now, I have not seen this on the exam since the 80s. Oh, no. Yeah, late 80s. Okay, Lizzie? They have not asked you to use a definition for a derivative. Now, they could do that for the absolute value because it works out really quite nicely. Not to say that it's not fair game, because it is fair game. So they could ask you this year on a free response to use the definition of a derivative. Possibly do that. I haven't seen it for a long time. However, on the multiple choice, when I've had the multiple choice to look at, I've noticed that they have these limits for you to do, and you go, oh, that's just the derivative of, maybe it's the sine function. And to do the derivative for the sine function using the definition, I have to use an identity, which is still on the board over there. Okay, Sam? So that's the reason we have to know this. I don't think they're going to make you use the definition. They could. But more than likely, you'll have to do a limit. You're going to say, oh, it's just the derivative of x squared. And you guys know the derivative of x squared. It's just 2x, right? So it's easy. Okay, which we aren't doing yet, but we will. Now, certainly you can use a derivative. If it's a line, then the derivative is just the what? Slope. So these are just your notations. I'm just reviewing those. So f prime of a is equal to the slope. Not crazy about this notation because it doesn't say how something changes as something else changes, Grant. So when I do a derivative, it's the change in y as x changes. So when you do the slope of a line, you are changing x. And the question is, how does the y change on that line? And that ratio is the slope. So you can't just talk about the change in y. It's not good enough. And the reason why students have troubles with, Duncan, implicit differentiation is because they don't realize it's the change in y as something else changes. Usually it's x. So the problem with f prime of x is it doesn't tell me with respect to what. Okay. A derivative is a rate of change. Instantaneous rate of change, that's your speedometer. There's not much to write here. Okay, Eric, question? That's when we don't have y solved for explicitly, like y equals. And we'll do that. It's like 3.8 or something. So the plan is we'll finish up this chapter, test on it. And we did fly through this chapter. We're going to fly through the next chapter, test on that a little bit into second quarter, and then we'll start chapter 8. And I'll have to review integrals a little bit with you when we get to chapter 8. But it's so different. Today's Tuesday. Okay. Now, what's velocity? It's the change in the position. Whoops. It's the change in the position over the change in the time. Position, that's an S, sorry. Now, this is the average velocity. Velocity is a vector. Okay, what does vector mean? Has magnitude and direction. And that's why we do the parametrics. They look different, but it's exactly what you're doing in science class and physics class, where you're talking about the velocity in the x direction and the velocity in the y direction. And what's this called? The vector, the resultants, right? Do you remember that? Who's in physics? Have you seen that yet? Yeah. Well, that's just parametrics. Velocity in the x direction, velocity in the y direction. That's all it is. The math people make it look different than the physics people. When you realize they're the same thing, I think the physics people actually do it easier. Quite honestly. Now, what's the speed? The absolute value of your velocity. Now, we haven't found out how to do that. Actually, we might as well introduce it. It's not in this section. But what if I wanted to find the length of this segment? What would I do from physics? The velocity in the x direction squared plus the velocity in the y direction squared has to equal the magnitude of my velocity vector squared. So how do you find v? This is going to give you this. The square root of v sub x squared plus v sub y squared. By whose theorem? Pythagorean. Okay, you've seen it now once. I don't expect any kind of long-term learning on that yet, but you will see that again and again and again. And that you have to know in the exam. Because we haven't really talked about what v sub x is. But we will be right after you come back from MEA break. We're going to go right into parametrics, and I'll be talking about that. I'm going to introduce it early because you have to have that. Cartesian function, that's just the xy's. This is the velocity in the x, this is the velocity in the y. Okay, velocity has both magnitude and direction. Now you can do part of the quiz. Okay, this is C prime. Now, this is really important. That's as good a start as I can make. It's really important to do this because they've been asking this question on the exam the last several years. Unfortunately, you have to interpret, and you have to be very particular about it. Usually there are 3 things you have to talk about. If C is equal to your cost of producing something, and if you want to go into business, and you're going to be producing some units, producing X units, what does C prime of X mean? Well, let's do the average. It's the change in the cost divided by what? You always have to talk about what's relative to something else. The change in the number. And if they give you an actual value, like 3, you have to be particular about what that 3 represents. If they give you a negative 3, you have to worry about that negative sign. Okay? So you're going to have homework questions. You need to practice these. What does this mean? It means as the number of units, I'm going to say changes. I don't know if it's increasing or decreasing. Changes. This represents how the cost changes. Now, that's only one piece of the 3 things, because when you do this on the exam, you're going to have a number there. And then you're going to have to be changing that. Oh, what? Pardon? I still can't hear you. I don't know. I never took econ or anything like that. So I don't know. But if you're doing into business, this is the kind of calculus you're going to use and talk about profits and stuff. But it can't be just the change in your cost. That's not good enough. It's the change in the cost as that you change the number of units. Does that make sense? The cost, if you only make 1 unit, if you make 10, is your cost different? If I make one thing or I make 10, isn't my cost different? Yeah, my cost increases if I make more, maybe not linearly. I may have my best cost when I make 100 units. Because to make the first unit, I got to make the mold or whatever it is. I have to do those plants. That's expensive. But the more units I make, then my cost usually goes down. Okay, how about this one? If P is the population at time t, what does P prime of t mean? Now, it's the instantaneous. But I like to look at the average because that helps me figure out what words I want. So P prime of t is approximately the change in the population as time changes. So if you were to talk on the phone and somebody says, I want to figure out what P prime of t means, you would say it's the change in the population as time changes. Okay, Grant? And that's what we're looking for. And they're only going to ask you things like that, I believe. I don't think they're going to ask you for numbers, but you'll get to numbers. I can bring up those exam questions, and that was at least in 2 free response questions this year where you had to interpret. So the only way you're going to get good at that is to practice. So yes, you need to do the homework because we really don't have a lot of practice on that. We didn't do much of it last year. Okay, that's the first part. I might as well get this all done today, right? And that's just a blank slide. Okay, and you may have some questions on homework, so we could be doing those too. And where's my other one? There it is. Then this is the other pink one. And it just gives you, and I'll let you do this on your own. Write the definition for a derivative. They put it all in one section, so I changed it. Well, it's continuous. This one's done. Definitely done. And then you could draw your own curve in there and do that. But I'm not going to take your time to do that. You guys know what that is. What are the notations for derivatives? Do you remember? It's even one of them. dy dx f prime of x Well, that's kind of like this. This is the average, delta y over delta x. That's the average rate of change. Then this is derivative operator, which we haven't seen too much in the books we've used because it was in our old book. But sometimes I like to use that just as an operator, like a plus sign. It's kind of nice, but it says with respect to x. And the other one is really the same as f prime. It's y prime. It doesn't even tell me if I have an x there. This at least gives me the x. Because y could be a function of time. This is all 2-7. The author put 2-7. In the old book, it was 2-7-2-8. Now it's all in one section. Okay. What does it mean to be differentiable? Do you remember what differentiable means? You can find a derivative. What has to be true about the function? F of x must be continuous. You're right. We can list those. We will. And then you're going to get a little bit of logic today. If you haven't studied logic, that's a whole course you could take in college. It's actually quite interesting. If the function is differentiable in an open interval, then it's differentiable at every point in the interior. Okay, a function is differentiable if the function is continuous and the derivative exists. So let's talk about, because I don't really have a space on there, but let's do that. Where do derivatives not exist? Where are functions not differentiable? What doesn't exist? Not differentiable at a point, call it C. And Duncan, what'd you say? Okay. At any kind of discontinuity. Does it make sense that f of C must exist? If you have a hole, how can you take a derivative where there's a hole? Certainly the limit exists, but can the derivative exist there if the function doesn't even exist there? No, it doesn't even make sense, does it? Okay, so to be differentiable, the function must be continuous. What's wrong with absolute value? You're right. Sharp corner. Now, in last year, they broke this into two kinds, sharp corner and also a cusp. A cusp would look something like this, maybe like a wave. But that's, to me, it's a sharp corner. And that's okay. Just recognize either way, that's a problem. Anytime the slope changes abruptly. Yes. Slope changes abruptly. That's like driving your car and you're in reverse and you automatically shifted it to forward. What's going to happen if you're going 2 miles per hour backwards? And you shift into drive. You're going to ruin your car, right? Your parents will not be happy with you. Okay. See, when you drive a car, your velocity has to go to 0. Then you shift back. Now I have a stick, so I can fudge around with that a little bit. Just put the clutch in. But it's basically the same thing. Actually, you'll grind the gears if you do that. And then somebody else, I think Lizzie said, what did you say? Vertical, remember? Non-line test, vertical, tangent. Too many wiggles would be in the continuity piece. Right, can't do it if there's too many wiggles. Okay, Eric, put your phone away, please. So if I have the cube root of x, it looks like this. And in fact, I bring up my Inspire. It's a really nice picture. If I look right there at where that corner is, that's a vertical tangent. I always forget about the vertical tangents, but they tell you on the exam. They actually, on the multiple choice, will say, and there's a vertical tangent here. To me, it's a gimme question, but obviously the kids don't always get it right. Okay? They even tell you it's discontinuous at certain points. You say, and then the question is, where is the function differentiable? Or where is the function discontinuous? I mean, it depends what the question is. So those are the 3 things to look for. Any type of abrupt change with a continuous curve, a vertical tangent on a continuous curve, or a curve where there's a break. No breaks. So the step function has problems at those steps. So should we try the next problem? Ready? And we already know where this function is not differentiable, but what if they asked you to do this on the exam? No, you're not. Should we draw the picture? It's not differentiable at 0. And we are going to define the function. Okay, there's the absolute value function. But we're going to have, they might ask you to use the definition of a derivative to show it's not differentiable. Okay, so we know it's not differentiable at 0. Now, for x is less than 0, what is our function? Let's put f of x here, and let's put f prime of x here. What is my equation? Well, let's do the easy ones. When x is greater than 0, what's my value? What's my function? Y equals x. I just put x there. Okay, Grant? Grant, if x is less than 0, what's y equal to? Don't help them. And x equals 0 is what? 0. Now, we can use the definition of the derivative. Let's just use derivatives. What is a derivative? It's what? It's the slope, right? What's the slope on the left side? -1. On the right side, it's 1. And here, it does not exist because What is a derivative? If I'm coming in from the right side, it's the limit as h approaches 0 from the right of the absolute value of x plus h minus the absolute value of x all over h. That's my definition, right, Ori? And what x value are we looking at in particular? Because I want to make this really easy. X is equal to what value? 0. So if I come in from the right using my definition, then this is the absolute value of h minus 0 over h. But if I'm coming in from the right, do I need that absolute value symbol? No. So this is just h over h, which is 1. There's proof that the slope is actually 1 on the right. Want to try the left? Do you know how to do the left? Do you? The limit as h approaches 0 from the left, and let's go ahead and substitute it in. It's 0 plus h minus 0. It's just the definition of the derivative over h. Grant, what does that give me? It gives me the limit as h approaches 0 from the left of the absolute value of h over h. Well, what's the absolute value of h from the left? I've got it. It's negative what? What's the absolute value of x from the left? It's negative x. So this is negative h over h, which is negative 1. They could ask you to do that on the free response. Okay? But reason why I wanted you to do this is because, remember, a derivative is a limit, right? Okay, You don't see the limit when I do this part right here, but if I write it this way, the limit from the left is negative 1, the limit from the right is positive 1. What's true about the limit at 0? Using our limit properties, it doesn't exist because the limit from the left as x approaches 0 from the left of, and it's really the absolute value of x over x, of my function, I'll just put it this way, does not, f prime of x, does not equal the limit as x approaches 0 from the right. I want you to realize their limits. And the slope from the left, because it's the limit, has to equal the slope from the right. So those limits are not the same. Sorry, does not equal. Therefore, remember the symbol for therefore, 3 little dots? The derivative does not exist. Yes. You like that? Math people are very lazy. That's why we invented all the stuff you don't like about math, but all those symbols and all the rules. We just shortened it down, that's all. Just shortcutted it. It gets, well, when you get into college level math, it gets kind of tricky. This still is pretty concrete compared to what you're going to do if you major in math. It gets very abstract. No, they don't use numbers. A calculator is worthless. But if you like proving things, that's what you do if you major in math. You do a lot of proofs to get your PhD in math. I know. I just want you to be aware of that. Nobody told me that. I was in my junior year before. No, I was in my sophomore year before I realized that. Because I was a year ahead because of AP credits. I finished my math degree at the end of my junior year. Yeah, well, you guys would too. You're in Calc 2. I didn't even have Calc 2 at that point. Okay, ready? I did some stuff over the summer to get completely caught up. Now, this is the logic stuff, and I don't know if you know about converses and contrapositives. Well, it's interesting stuff. I think it is. This is a theorem. Now, a theorem is something I can prove. We are not doing proofs in this course, thank goodness. Okay, if the function is differentiable, then it's continuous. Is that true or false? If you have a differentiable function, must it be continuous? True. Okay. The converse is reversing that. So let's write it out. I'm going to switch the if and then. I just hit that by accident. You guys didn't have that chair there. Have a little more room. Okay. So I'm going to reverse it. If a function, okay, Ori, is continuous, then at x equals a, if I reverse the if and then what's my conclusion? Then f is differentiable. Is that true? If you have a continuous function, must it be differentiable? That's false. Give me an example. We just did one. Absolute value. So if the theorem is true, its reverse or its converse need not be true. It might be true, but there's no guarantee. Now, the contrapositive is the converse, but you insert a not statement in there. So I'm going to write it out, but I'm going to put a not in here, and I'm going to put a not in there. And the symbols they use in logic would be P implies Q. If that's true, does Q imply P? Can you reverse it? It's just saying reverse. No, you can't do that. Okay, so let's write out the contrapositive. If F, and then you can do the nots too. I'll do that in a second. If F is not continuous at x equals a, then F is not differentiable at x equals a. Is that true or false? It's true. No. The contrapositive, the not would be looking like this. So here's the theorem, here's the converse, and the contrapositive in that little symbol notation would be not Q implies not P. So if you take a logic course, they have these things called truth tables. And they're made up with these little symbols, and you have to follow it. It's very good for your logic. It's been a long time since I've taken logic. But it's kind of interesting. It's actually, and that's a whole course. And I really highly recommend it to everybody to take a logic course because it would benefit you in life. Especially if you want to be a politician or a lawyer and you want to argue something, you definitely need to know how to do logic stuff. Okay, you're not being tested on this, but I thought it was kind of interesting. Only Ori. Okay, we already did this. Where a function's not differentiable, so our sheet's complete. Holes. Okay, discontinuity. Any kind of discontinuity. Where else? Corners, sharp turns. How about you call it just sharp turns? Like if you're going forward, you go, ooh, I want to go back that way. Have you ever spun the car around? Yeah, it's not fun. Where else? Vertical tangents. You do. Everybody uses derivatives all the time. All the time. You may not call them that, but that's what they are. Okay, Eric? Okay, can you get the notations in here? Did I skip something by accident? Oh, you're right. I think I did. I bet it's at the bottom and I missed it. Oh, I'm just missing it entirely. Hey, you guys, how do you know if a function's differentiable? What if you zoom in on a differentiable function? What's it look like? Straight line. You get a line. Have you done the zooming in on the absolute value? We did it last year. I don't think I did it this year. It's really nice in the Inspire because it's very easy to see. But if you keep zooming in on the corner of the absolute value, you'll still keep getting the corner. It looks exactly like the original graph. Actually, it gets me into self-similarity. Okay, that's the answer to your derivative lab. What happens? Why does that work? Because you get a straight line. Okay, notations. Okay, give me an alternate notation for f prime of x. dy dx. That's my favorite. That's Leibniz. What about f double prime? Remember what the d squared y dx squared. Now, I cheat a little bit to remember it. This is like taking the derivative. That's the operator. Says take the derivative of whatever follows. It's not, the operator is not dy dx. It's this d over dx. Now, so it's a little cheating way to remember it. How many d's are there? Squared, and I should really have dx in parentheses squared, then it would match algebraically, but it's a nice quick little way to do that. What does this represent? Dy dx squared. That's m squared, right? That's the slope squared. That is not the second derivative. You see the difference between this one and this one? They look really the same, but they're not. How about the third derivative? Okay. Right, you do the nth. Do I have the n? Oh. So this is d, and with a little Roman numeral 4 over dx. I've never seen these. How often do we do that? Not too often. And the nth, not in the real world. Taking the derivative n times. So when we get to the rules for derivatives, I'll let you prove the power rule. But we're going to get there. Yeah, we're going to get there right now. If my function is position, what does the first derivative represent? That's the velocity, right? Because it's the change in the position divided by the change in time. That's what we mean by your speed. If you go 50 miles per hour, Eric, that means in 1 hour I've covered 50 miles. That's what it means. It's how fast your wheels are turning. Okay. What if I do s double prime of t? That's the acceleration, right? That's the change in the velocity as time changes. Right? But that's still not what causes you troubles in car accidents. It's the third derivative. It's f triple prime of t. It's called the jerk. In your book, it's called the jerk.
Actually?
Yes. So s triple prime is the change in the acceleration as time changes. So if you're accelerating and somebody hits you head on, what happens to your you're accelerating, hit you straight on, your acceleration is going to change, isn't it? And that's the jerk. That's the part that hurts you in the car accident. It's not the change in the velocity, it's the change in acceleration. There is nothing special for that. That's it, just the three. And everybody asks me that every year. I go, well, I don't know of anything special. Maybe if you study mathematics, there may be some deeper meaning to that. But right now, I don't know.
Why'd you just write T to 4? Why'd you write IV?
Because I had IV before.
Well, you had 3 lines before, now it's 3.
No, this is Roman numeral 4. I could have written it. Yeah, I could have done this. I would have preferred to write that, to tell you the truth. Okay. I keep bumping that. Okay, I think that's it. So now, what should you be working on? Homework. Now, I don't make the lessons long because I want you to work.
X is on the, it's like beating it.
Oh no, it should be of X or X. It should be F. There. Happier. Now, do you have questions on any of the homework that you want to ask me about? Of course, you can't ask questions if you haven't tried it. Okay. You have any questions on homework? Anything you want me to work on the board? It's going to get harder. Then on 2.8, we're going to talk about what the derivative means, if it's positive, negative, concavity, increasing, decreasing.